Guys, welcome to all of you. Let us see a question on Norton's equivalent circuit. In this circuit, it is asked to find out the Norton equivalent circuit of this given circuit. So let us see how can we solve this circuit. We have to find out Norton equivalence across terminal A and B. First of all, let us see how to calculate Norton equivalent current source IN. In this circuit, let's assume that across terminal A and B it is short circuited, and we need to find out short circuit current across terminal A and B. Here assume that this is node 3, this is node 1 and this is node 2. Now apply KCL at node 1, then we can find out that current in this branch will be equal to 0 minus 24 upon 6 plus this current is leaving this node, so it will be in positive sign and current will be plus ISC. Current in this branch will be plus 0 minus V1 upon 3 equal to 0. We rearrange the equation and equation number 1 will be found. Now if we apply KCL at node 2, then we will find out that current in this branch will be equal to V1 minus 0 by 3. It is written here, plus this 2 ampere current is leaving this node, so it will be positive in sign, plus 2, plus let's assume current will leave in this branch from this node, then that will be equal to V1 by 3 equal to 0. Then V1 value can be calculated by minus 3 volt. We put this V1 value in equation number 1, then we will find out short circuit current ISC in this branch will be equal to 3 ampere. As we know that in Norton equivalent, short circuit current is equal to Norton current, which is the current source of the Norton equivalent. Now let us see how to calculate Norton resistance of this circuit. For the calculation of Norton resistance, we have to short circuit the ideal voltage and open circuit to ideal current sources. As we see that here a voltage source was connected, so we have short circuited to this terminal, and here 2 ampere current source was connected, so we have open circuited to this terminal. Now if we will find out our equivalent across terminal A and B, then we can see that these 3 ohm and 3 ohm resistance are in series, and equivalent of this resistance will be parallel to 6 ohm resistance if we find out our equivalent across A and B. So our equivalent will be 6 ohm parallel 3 ohm plus 3 ohm, that will be equal to 3 ohm. So we have found out R equivalent. This R equivalent value will be equal to Norton resistance Rn. Now we can design Norton equivalent resistance of the given circuit in the question. Norton equivalent of this given circuit will be equal to IN is equal to 3 ampere, which is calculated above, and Rn is equal to 3 ohm. These current source and resistances will be connected in parallel, as we have seen in the concept of Norton equivalent circuit. So this is our Norton equivalent circuit across terminal A and B.